Okay, technical terminology. That's what we're going to be talking about right now. So, exacting terminology from all of our standards, it prevents something that is extremely dangerous. It prevents where we use one term with multiple definitions and we establish what it means through context. You don't want to do that. For example, from the Bible, there's this term cleave. And when it's used in the Bible, it typically means that you're joining together. It's used to talk about marriage, how two people become, one unit. They cleave together. However, cleave is also what an axe does when it cuts through something. We have our axe. It cleaves through the log. Chop. So, we do not want to do this type of cleave if you're talking about a marriage, I would like to keep all the axes out of my marriage. No, no, no. So cleave has multiple definitions. And depending on what the context is, depends on which one you use. So in our terms in GD&T, we do not do that. That's why we have such exacting terminology. So every word and every symbol has a particular meaning. Another thing we want to avoid is colloquial terms, okay? Terms of phrase. But this can lead to confusion. There's a really good example of just like, that's a good turn of phrase that would come in handy here. Like it'd be a piece of cake or something like that, If somebody has no idea what you're talking about, then they're like, okay, it's a piece of cake. I've never made a cake. Does that mean it's hard? So it's really super hard to do? We want to avoid these so meaning is clear, okay? If it's just a phrase or one of those things, like it's a catchphrase or something people say, avoid it. You don't need to use it. Use the terminology built up in GD&T. Okay, now what are some things that you're going to get when you are doing all this documentation? What are you going to be giving to other people with that exacting terminology? Well, you're going to have a product definition data set. That's the entire collection of documentation which is used to describe the requirements for your product. Okay? That might be the model with all the annotations. Might be multi-view drawings, a notes list, just for anything extra they need to know. And also a list of required materials, because if it requires adamantium, well, guess what? Most people don't have that. So it won't work. So you give this to the person and they should know exactly what you want to do. Now let's look at a couple of those things we just talked about. Like for example, model geometry. Usually when we're talking about this, we have a 3D model, not a two-dimensional model, though you could have built a prototype that you want them to build from. So your model geometry will define the part, okay? And sometimes your supplemental geometry will help to communicate requirements. It might make it easier for them to understand what's going on there. Model geometry is all the defining geometry of the part itself. Now, supplemental geometry, it's not part of the model, so it's not something that's physical, but it communicates requirements pertaining to it. For example, right here, the supplemental geometry is this line, okay? It's not actually part of the geometry. There's no line on the surface that you would see if you would look at the real part. You're going to use that line to define something. Other things you might see as supplemental geometry is just, you'll see a little square on the surface. There's no square on that surface really, it's just to show you that something's happening over an area. Okay, and finally our annotated model attributes. Dimensions and node requirements that may or not be visible, but are available by interrogation of the model. So sometimes things are just too complex to put a dimension to, especially if you have something that looks kind of like this. Let's just imagine it's a vase, okay? It'd be very difficult for me to put all the dimensions necessary to define that vase. And in that case, I would probably give some sort of 3D model and say, okay, I get this is hard to look at or hard to figure out, but just look at this and you'll get what's going on. As they would go into the part and they could figure out exactly what the dimensions are using that, and they could make a machine or they could test their designs based on that geometry. It might also be because it gives you extra little details right here. Okay, extra little details. For example, this 0.88 right here, that might be what's shown in dimension. There's a lot of things that happen in SOLIDWORKS, it'll show that. But it might tell you, like, okay, well, if you actually measure things in your SOLIDWORKS model, well, it's not actually 0.88, it's 0.875. It's just when they rounded it, it turned into 0.88. So any annotation is visual textual content in a model to establish dimensions, tolerances, notes, whatever it is. So those numbers, annotation. That number right there, annotation. Anything I'm adding to make sure that people can understand it is annotation. So with that, I hope that makes a little bit more sense now, and I'll see you all next time. Bye-bye.